Okay, so here's another system with three variables. Now since there's only two equations, this is definitely going to have an infinite set of solutions. And you could think of, like, since this has three variables, and so does this, those are like two planes. So imagine like two walls, right? Those are planes. When two walls intersect, like in the corner of a room, right? So you got one wall here and another wall there, all right? They intersect in a line, which would be like that corner of the room. So that's why this is definitely going to have infinite solutions. And anytime you have more variables than equations, there's going to be infinite solutions. Alright, so what you do is you just try to eliminate a variable. So since we have opposite coefficients with our z's, we could just add these together. So we get 3x minus 3y equals 3. Alright, so x is gone. And now there's really nothing else we could do because we just used those two equations. So there's no other new equation we can make. Alright, so we know that there's infinite solutions. So now we want to express like x in terms of y or y in terms of x. It doesn't matter. So if we just divide everything by 3, we get x minus y equals 1. And we get x equals y plus 1. Alright, so now if I were to like write this as an ordered pair in terms of x, right? So like x, y, and z. Well then we can leave x as a we're going to now replace x with y plus 1, and then y is going to stay as y, and then for z, now we want to see what z is in terms of y. Alright, and I just chose to put everything in terms of y. It doesn't matter. When it's all said and done, I'm going to introduce an independent variable like c. Alright, so now I'm going to take that top equation and replace x with y plus 1. Alright, and 2y stays plus z is equal to 2. Okay, and then so now I'm going to solve for z. So I get negative y plus 3. Alright, so negative y plus 3 equals 2. So I get negative y equals negative 1. Oh wait, I'm confusing my z's and my 2's. Hold on. Okay, sorry about that. So I fixed that. So I highlighted z in red, so it didn't get confused with the 2. Alright, and I solved for z, and I got z is equal to 1 plus y. So now in our final answer up here, we can express everything in terms of y, and we could see that, okay, x and z are the same thing because they're both y plus 1. Alright, so if we were to let c be a real number, alright, like your calculator does, one way we can express this solution is as c plus 1, c plus 1, alright, which means things like 2, 1, 2, or 5, 4, 5, or 199, 100. Those would be ordered triples that work in both of these equations over here. Alright, now notice how y, right, that middle c, is 1 less than x. So another way you could express it would be like this. It would mean the same thing. It's just putting it in terms of x and z versus y. Alright, so for both of these ways to express the infinite solutions, alright, you get numbers like 6, 5, 6, ordered triples that work. Alright, so anytime you have less equations and variables, you're definitely going to have infinite solutions. Or maybe no solutions, but in this case, infinite.